Hi, in this video we look at an optimization problem involving more than one variable. The problem is taken from 10 Applied Calculus. An apple orchard has an average yield of 36 bushels of apples per tree if the tree density is 22 trees per acre. For each unit increase in tree density, the yield decreases by 2 bushels per tree. How many trees per acre should be planted to maximize the total yield? Now, a problem like this can seem intimidating at first as it contains a lot of information. First of all, we notice that it is an optimization problem since there is something to maximize, here the yield. Then we need to figure out what the variables are and how they relate to each other. The trick here is to try to organize the data, draw a figure, do whatever helps to understand the information given so that we can identify the variables and the relationship between each of them. In this problem, the total yield is related to the yield per tree, or equivalently, the number of bushels per tree, and the tree density. These two variables are related to each other as mentioned in the second to last sentence, which says that for each increase in tree density, the yield decreases by 2 bushels per tree. We can try to illustrate on a graph or in a table that information. Here we have created a table with 2 columns, one for the number of trees per acre and one for the number of bushels per tree. We're told that with 22 trees per acre, we will collect 36 bushels per tree, and we add this to our table. If we increase the number of trees by 1, the yield decreases by 2 to reach a value of 36 minus 2, which is 34 bushels. We add this to the table as well. So with 23 trees, we collect 34 bushels. Similarly, with 24 trees, we collect 32 bushels. If instead we decrease the number of trees from 22 to 21, then the number of bushels collected will increase by 2, going from 36 to 38 bushels. With 20 trees, we would collect 40 bushels. Now that we understand a bit better what the problem is, we define the different variables in the problem. First, we're asked to find how many trees per acre should be planted. This tells us that the number of trees per acre should be one of the variables. Let x be the number of trees per acre. Second, we're asked to maximize the yield, which is the number of trees per acre times the number of bushels per tree. We can define these two other variables as W, the number of bushels per tree, and Y, the yield per acre. To understand better how the variables are related, we can take the values of the previous table and add them as points on a graph. On this graph, the horizontal axis is the x-axis, and the vertical axis is the w-axis. We see that the point lies on a line, and by going forward by 1, the line goes down by 2. Therefore, the slope of the line is rise over run, so minus 2 over 1, or just minus 2. Given the point 2236 and a slope of minus 2, we can write the equation of the line using the point slope form. This gives w minus 36 is equal to minus 2 times x minus 22, and solving for w, this gives w is 36 minus 2 times x minus 22, and by expanding and connecting like terms, we get minus 2x plus 80. Now we want to maximize y, which is the total yield, and that's the number of trees times the number of bushels per tree. That is x times w. Replacing w by minus 2x plus 80 gives y is equal to x times minus 2x plus 80, which is minus 2x squared plus 80x. Therefore, the problem is asking us to maximize y, which is minus 2x squared plus 80x, subject to x greater than 0. Now this last constraint reminds us that the number of trees per acre is a positive quantity. Because the interval is open, the maximum will occur at a critical number. Therefore, we first compute the derivative of y. So here y prime is minus 4x plus 80. This derivative is always defined and y cannot have any corners, in which case y prime would be undefined. In this case, a critical number will be a solution to y prime equals 0. Now, minus 4x plus 80 is 0 when 4x is 80 or x is 20. And to show that x equals 20 is a maximum, we could show that y increases for x less than 20 and decreases for x larger than 20 using a sign chart of y prime. That's called the first derivative test. Or we could show that y is concave down by showing that its second derivative, y prime prime, is positive. That's called the second derivative test. Now, in this case, since y prime prime is pretty easy to obtain, we try the second option. We can always come back to the first option if that doesn't work. Now, y prime prime is minus 4, and that's clearly negative, and it makes y a function that is concave down. So this proves that at x equals 20, there's a maximum. Finally, at the maximum, the values of the variables are x equals 20 trees per acre. W is obtained by replacing x equals 20 in w equals minus 2x plus 80. So w is minus 2 times 20 plus 80, which is minus 40 plus 80, which is 40 bushels per tree. The total yield y is x times w, so 20 times 40, which is 800 bushels per acre. Now you should at the end of any word problem take the time to summarize your answer in a complete sentence. For example, here we could say that 20 trees per acre should be planted, and the yield in this case would be of 800 bushels per acre. Thanks for watching.